Hello and welcome. My name is Aidan Maune, and this is my presentation on the 1968 Indian monsoon floods. Up first, we're going to be talking about some of the weather patterns that ultimately caused this flooding. So during the 1968 Southwest monsoon season, there were 6 depressions that originated from the Bay of Bengal. 4 of these depressions moved westward and the other 2 eastward, leaving a deep land depression over the Bay of Bengal. This depression caused the formation of a cyclonic storm, which ultimately caused the mass flooding of 1968. So these monsoons are seasonal, as monsoon season comes every year from June through September. But this flood was primarily driven through heavy precipitation and storm surge from the Indian Ocean. And here we see the isohyoidal pattern of the 1968 monsoon from October 3rd through October 5th. Here you can see this is that West Bengal area that we were talking about, and you can see how this storm kind of just hovered and sat and dumped rain right in this area. So now we're going to be talking about the magnitude of the flooding relative to the Earth and time. So India faces dangerous flooding to monsoons almost every year. And from 1950 to 2015, the amount of extreme precipitation events multiplied threefold. During the 1968 monsoon season, 30 of 31 of the meteorological subdivisions of India experienced greater than 50% of average rainfall. Each monsoon season, approximately 32 million hectares of land are affected by the flooding, and it's hypothesized that the Indian monsoon season will progressively become more dangerous due to carbon emissions from India. To speculate on that a little bit, seeing how damaging this storm was in the 1968 monsoon season and how progressively worse they've gotten. I know there was another terrible one that happened in 2014, but with carbon emissions around the world emitting the CO2 into the atmosphere, that's ultimately causing glaciers to melt, that's causing flooding, and it's also making monsoon season worse. So here we have a graph, well, not a graph, here we have a calendar graph that is showing us the rainfall that's different from average. And I guess the baseline here is 1 inch of rainfall. But here we can see this is depicting, this little sign here is depicting greater than 50% of average rainfall. And if you look at the number of these along this chart, it's easy to determine that over half of the season and half of these meteorological subdivisions were just getting poured on. So next we're going to be talking about the societal and economic impacts of the flooding. So to start off, during the 1968 monsoon floods, there were 4,892 reported deaths, and these were caused by drowning, disease, lack of resources, pretty much anything that you can imagine a storm would damage. People were dying from it. During the season, 1.1 million tons of crops were lost due to floodwater. This ultimately destroyed a massive part of India's economy in kind of the East Bengal area, as crops were a main source of income during this period of time. And as we can see here, $3.5 billion of infrastructure damage were caused by the floodwater. So we can just see, just through these big numbers here, how much damage the storm caused. Next, we're going to be talking a little bit about the water quality. As you can imagine, a mass flood is going to move particles from highland to lowland, and these particles are going to seep into groundwater, which is then converted into well water in some cases, and people are going to be drinking from this. People are going to be potting this water, and it's going to be infecting them with disease. It's contaminated, it's toxic, it's a shame, honestly, how damaging these storms are to the water quality. So up next, we're going to be talking a little bit about India's adaptation strategies to this continuous flooding. So kind of to mitigate some water during these mass floodings, along the Kerala River, 44 dams have been built, and during the worst of the flooding, usually all of these dams are open to move as much water as possible. In some cases, regulations have been placed for construction zones, preventing the construction of buildings close to water sources. Certain states have regulations that also require the construction of buildings in a manner that make them more flood resistant. And naturally, with all these regulations on hand, flat areas of high elevation no longer sustain buildings as they act for floodplains for water runoff. So gravity is pretty much doing its trick there. When water is dumped on high land, it moves to low land, and sometimes if it's in enough quantity, it will take out anything in its place. So it's evident here that India is taking a couple steps to do what they can to attempt to mitigate water and try and combat flooding. So that's the end of the presentation. I hope you enjoyed, and I will catch you all next time. Thank you. Goodbye.